All right, hey, how's it going? So something we decided to do, we get lots of calls, folks asking about, they'll call it a block and tackle, when it's actually correct pronunciation is tackle in that regard. But they want to know about building a mechanical advantage system. And I've taken lots of rigging physics courses, had lots of various training throughout my almost 30-year career. And I've working with lots of different folks. I've simplified a way to understand and calculate mechanical advantage in simple and compound systems. We're not talking about complex systems, because to calculate MA in a complex mechanical advantage system, you have to count units of tension. You have to trace the legs of tension. There's ways to calculate mechanical advantage. You can count the legs of rope that are supporting the load. You can trace your units of tension. You can measure. My way is easier. All right, if Marines can understand it, if firefighters can understand it, if I can understand it, that means it's really simple concept, because it is in regards to simple mechanical advantage systems. And what a simple mechanical advantage system with pulleys is your traveling pulleys, which are attached to the load, are traveling at the same speed of the load. And a compound system is just two or more, if you wanted, simple systems stacked on top of one another. If the last pulley, or another way to look at it, the pulley that's the closest to the hauler in your mechanical advantage system, if that's where the last pulley is, it's only a change of direction. You don't gain any mechanical advantage from it. And that'll make sense as we go on. If your rope in your haul system is terminated on the anchor, your mechanical advantage is always going to be even. All right? Do notice this star in the first rule, because that will always be referring back to that, okay? So the third one is, if the rope is terminated on the load, your mechanical advantage is going to be odd. Okay, you just always remember those two things. We don't need to count legs of tension or anything else. This is easy. To calculate your theoretical mechanical advantage means on paper what it is. We're disregarding friction and bend radius and everything else. So to calculate your theoretical MA is you count the number of pulleys in your haul system, not our changes of direction and our directionals, only what's in the haul system. You count those number of pulleys, you add one, that equals your mechanical advantage. And remember, that's in a simple mechanical advantage system only, not complex. All right, rule number 5, a compound mechanical advantage system is just two simple systems stacked on each other. All right, and then there's another term that you'll hear thrown around, a piggyback. That's a compound mechanical advantage system that's two of the exact same type of MA system. So two 2-to-1s stacked on top of one another is going to create a 4-to-1 piggyback. And then to count a compound system, you just multiply. So if I put a 2-to-1 on another 2-to-1, we get a 4-to-1. A 2-to-1 and a 3-to-1 is a 6-to-1. A 5-to-1 on a 3-to-1 is going to give us 15-to-1. And something to keep in mind, one individual, all right, on level ground with proper footwear, gloves on a rope, is easily going to be able to impart 125 pounds of force, of pulling force. So with a 3-to-1 mechanical advantage system, that's going to put us at 375 pounds that we can, theoretically lift, all right? So that's your basic rules. Now, where I've got this star, and we talked about the last pulley, or the one that's closest to the hauler in the MA system, it's only a change of direction unless it's attached to the load and the load can haul. And an example of that would be our double rope climbing system. Both legs of that rope, so my 220 pounds is 110 on each side. Those are both terminated on my harness, but because I can haul, that is a 2-to-1 mechanical advantage, theoretically. All right? Or another example would be when you put, your truck has a winch on it, you're stuck, you put a pulley up on a tree, bring that winch line back around, put it on your shackle on the bumper and start hauling, you just created a 2-to-1 mechanical advantage system. You doubled your purchase. All right, so real quick, got a pulley hanging here, and we sell a kit at WesSpur. We call it the ZRig kit. And what I want to get across to you is with that ZRig kit, we can build a 2-to-1 double whip, is what it's commonly called, or 2-to-1 with a change of direction. We can build a ZRig with progress capture, obviously, and we can also, with the addition of just one more rope, we can build a 4-to-1 piggyback. All right, so right here, I've hung one pulley. This is just a high directional, all right? I clip that on the load. I start lifting. I have no mechanical advantage. If that's 100 pounds, I have to overcome 100 pounds to lift this bag, right? All that is a change of direction, okay? But now, right, so now we've just created a mechanical advantage system, right? And so if we look at our rules of mechanical advantage, the last pulley in this system, or the one that's closest to the hull, okay, this is where I'm inputting my force, that's the output, okay? So that pulley that's closest to me is not giving us any mechanical advantage. It's only a change of direction. This traveling pulley, all right, that's on this load, so we go back to our rules, so we know that this isn't giving us mechanical advantage. So we count the number of pulleys in our hull system. We have one pulley. We add one, that gives us 2 to 1 mechanical advantage. Okay? Does that make sense? Or, you know, I call this a 2 to 1 with a change of direction. It's also called a double whip, right? Because we go back to our rules. Our rope in our hull system is terminated on the anchor, so we know that our system's going to be even. Real simple, real easy, all right? Okay, so now with that same, what we call our ZRig kit at WesSpur, with those same 2 pulleys, 2 prusiks, and 2 carabiners, I've created a ZRig, or a 3 to 1. And why is this a 3 to 1? All right. Well, we've got 2 pulleys in the system. Okay, the rope is terminated on the load. All right. So going with our rules of mechanical advantage, we know that we're going to have an odd system. Now we go back to the rules. We got 1, 2 pulleys. All right. This pulley, that's the last pulley in the system, as I call it, or the one that's closest to the hull, is giving us mechanical advantage. Okay. So we count our pulleys. 1, 2, we know it's odd. I go 1, 2, I add 1, that's 3. This is a 3 to 1 mechanical advantage, right? And it's set up here with the progress capture prusik. So as I haul and my load's going up, all right, if I have to stop to reset, that progress capture prusik back there on the anchor is holding the load suspended as I come up, reset my haul, right? Start hauling, okay? And one thing when you're building the haul field like this, if you can get it horizontal, that's better. And the thing you don't want to do, don't do this, all right? That's jerky. It's loading the anchors, you know, in different ways. We want nice steady pull. Just grab the rope, go for a walk, all right? If you have to reset, your progress capture prusik holds what you gained. You come up and you reset, all right? And like I said, you can see the load going up. All right, so remember when we were talking about our change of direction pulleys, how they don't count, all right? So when you're calculating your MA, remember you're only looking at what's in your hull system. This pulley here and that high directional, they're functioning as directional pulleys and changes of direction. I wanted to create a horizontal hull field because that's easier to reset, easier to work. When you're pulling a tree over, you may still want to do this. It gets you out of the path of the fall. And the other thing is, if you need to reset your 3 to 1 to complete the tree going in the proper direction, your traveling pulley, if you're running at that angle, you might not be able to reach it. So setting a horizontal haul field is oftentimes the best way to go, regardless of what you're doing. All right, so that's the ZRig, the 3 to 1 ZRig you can build with just 2 pulleys, all right? Next, we'll show you how to build a 4 to 1 piggyback, still only using 2 pulleys, all right? And all you need is 1 additional rope, and we'll show you that. Okay, so with those same 2 pulleys, it's in what we call the ZRig kit at WesSpur, just 2 pulleys. I've built a 4 to 1 compound system, all right? All you need in addition to your basic setup is just another piece of rope to attach to your haul line, okay? Now this rope is terminated on the anchor. So right there we know if it's on the anchor, we're going to have an even mechanical advantage system, right? So I have 2 compound systems. So my first system, I have 1 pulley. With our rules, we count that 1, we add 1, 2 to 1. And then on this other system, same thing. It's anchored, you know, other half of the rope, it's anchored on the anchor, okay? Or terminated on the anchor. So we have 1 pulley, we add 1, 2 to 1. So 2 times 2 is 4. That gives us a 4 to 1 mechanical advantage. Where you could use this is it's real easy to stack this onto a ZRig, all right? 4 times 3 gives us what? A 12 to 1 mechanical advantage. So with just 4 pulleys, 4 single shift pulleys, you can build a 12-to-1 mechanical advantage system that has progress capture, because if you stack the 4-to-1 piggyback on top of your Z-Rig is capturing, you know, the haul of your load so you can reset, okay? Makes everything nice and easy. So that's a 4-to-1 piggyback, all right? All right, so now what I want to talk to you about is we've built a compound system, and actually this compound system has 3 simple systems, all right? And I'll explain to you why. This right here is our 4-to-1 piggyback, which is attached to our Z-Rig, which is a 3-to-1, okay? So calculating our MA, we know we got a 4-to-1 here, we got a 3-to-1 there. 4 times 3 is 12. So overall, we have a 12-to-1 theoretical mechanical advantage. But something you have to keep in mind when you stack simple systems and create a compound is collapse rate, right? So the last system, or what I look at is the first haul system, is going to collapse quicker than the second, or in this case, quicker than the third. So you watch as I haul, all right? So I'm going to stop right there. Hopefully you can see this. I've moved 2 feet of rope, all right, on this 2-to-1, which has only moved a foot of rope on this 2-to-1. So to figure out your collapse rate, an easy way to look at it, let's just look at this piggyback, but look at the 2 simple systems in it. You ignore your first haul system, your collapse rate is the same as the mechanical advantage of your second haul system. So this is going to collapse at twice the rate of this, okay? Now, this 2-to-1 here is going to collapse 3 times as fast as the Z-Rig, okay? Because, right, this is the one we're calculating now, all right? So that's a 2-to-1 pulling on a 3-to-1. This is going to collapse 3 times as fast as that. And it'll kind of be hard to see, but so I've moved about 3 feet of rope right there. We only moved a foot on our Z-Rig, okay? All right, that's collapse rate, and we've built a 12-to-1 compound mechanical advantage system, all theoretical, all right? And our progress capture on our Z-Rig is holding, so because this is going to 2-block before this does, we'll have to have a reset, but that progress capture on the Z-Rig allows us to do a reset. If you just run just a 4-to-1 piggyback for lifting, where it's attached to your main line, you'll have to manage that slack that you create in your main line so that you can reset. All right, so that's simple and compound mechanical advantage systems. I hope we made it easy for you.